Hello Internet, and welcome to the fourth part of this video series. And this is exciting because behold, a successful print. Yeah, finally I was able to print this box, and in this video I will show you, of course, how I solved the problem and also the debugging process that I went through to find the issue. And the issue was unexpected to me, but yeah, let's see the print. So this print is with ASA. It has some warping, which I think is normal for that volume, and yeah, the quality is not bad. It's far from perfect, but pretty much that's what I would expect from this printer and from this size of object. And yeah, pretty much so. This thing is built without any support, without any supports here from these holes and these holes and this thing here that's indented in the wall. And yeah, it's not bad. At least it's something which is more from what I was able to do until now. Yeah, you can see some line separations here, and I can probably compensate that from the software. I can just bump up the filament amount for the first layer, and it will compensate for this. And I can process this a little bit to make it look better. Okay, so that's exciting, and let's go through the debugging process. Okay, so if you go to your printer, go to settings, then the V1, you can see the network that you are connected to right now. So tap on it, and here you can see your IP address, the printer IP address. We can use that IP address to SSH connect to the printer. Okay guys, let's examine the motherboard of the printer. Here is my microscope, and this is the motherboard. So this here is the display connector that I broke the watch. Then if we go down, this rockchip here is the main CPU. This is, I think, 32-bit ARM Cortex A7 CPU with some AI optimizations that they probably use for the spaghetti detection and the other AI features. This here is the non-memory flash chip. It's 8 gigabytes. Then here we have this mysterious switch that I have no idea what it is about. I tried pressing it multiple times, double clicks, press and hold, just no reaction from this switch here. So if anyone knows what it is, please share. Then this metal shielding here underneath is the Wi-Fi chip. Then just a little bit below that, here is the Wi-Fi antenna connector. Then after that is the buzzer. Then there is this connector here that it is not connected. And on my new motherboard that they sent me, this connector is missing. There is nothing here. So I guess this is, I don't know, maybe for testing and flashing the chips, something like that. Then here, oh, hold on, here, this is the USB controller chip. And then let me turn that around. This connector here is the 8-pin connector for the cable that is coming from the printhead. And I think basically only 7 out of these 8 pins are used. It's a 7-core cable that's coming from the printhead. And I think that 4 of these 7 cables are two 24-volt lines, positive and negative, and the other 3 cables are for the serial communication between the main board and the printhead board. So this, next to that connector, we have a 4-pin connector. I'm not sure what it is about, but probably that's the Ace Pro connector. Then these black wires here, this is the main connector that goes from the motherboard to the driver board. And I measured the cables, and basically on these 2 cables here, we have 24 volts. And on the other cables, we have a bunch of 5 volts and 3.3 volts. Then we have 2 4-pin connectors. And the first one that's next to the main cable, this is the USB connector. And the other 2 connectors, I'm not sure what they are about. This here is just 2 pins, so it's probably, I don't know, maybe a fan or something like that. And here, next to the display port, we have these 3 connections here. And these are the connections for the serial port that I connected to in order to access the file system of the mainboard, the motherboard. And they're labeled ground, receive, and transmit. The square pin is ground. Then, according to the labeling, this middle pin should be receive, and this one should be transmit. But I think that they are probably wrongly labeled, because when you usually connect to serial port, you connect the ground pin to the ground pin of your adapter. Then you connect the receive pin to the transmit pin of your adapter, and the transmit pin to the receiving pin of your adapter. So basically you are crossing these 2. But here, when I did the connection, I think that didn't work. So I switched them over, and it turned out that this middle pin that is labeled as receive is probably a transmit. So yeah, if you're doing that and it's not working for you, make sure you try them the other way around. And it turned out that that's probably not needed. And let me tell you why. So let's move that microscope away. And these are the files that I extracted from the motherboard. And so the main idea of that thing that I did was to find the zip archive password, because Anycubic denied me the password to give me the password, and they didn't show me a way to generate the works without password. So I tried to brute force it for 3 weeks. It didn't work, and I had to find a way to access these works, because from what Anycubic support is telling me, nothing is working. So what I know for these zip archives is that for these work archives is that they are zip archives basically with password protected files inside. So now that I know they are zip files, obviously if the code that is creating the zip archive, if it is just a script that is readable, human readable, I will be able to find the zip command. And I did a bulk search in all the files for zip, and here is what I found. So here we have an unzip command that is not zipping but unzipping, unarchiving a file, and I think that's related to the firmware update. And obviously they are password protecting the update files, and this is the password for that. It's hard coded here. But here in this script, this shell script, we can see the zip command that is creating the work archive and the config archive. And here is the password. I will add it to the description of this video. And that's the password that they use to protect the archives, basically. So here is the file, and this is the password, and it's working. I was able to extract the archives. And the other interesting thing here is this code. So basically what this code means is that so first, the Anycubic, when they ask for walks, they're sending you basically an archive, like this zip archive, that is with this weird name. And when you extract it, it creates a folder with this weird name. And inside this folder, there is a file with the same similar weird name. And what this weirdness here is just a base 64 encoded the actual name of the file and the folder. So if we copy that name of the folder, for example, and open a browser, and we look for base 64 decode. We can put that string here, and when we decode it, we can see that this thing decodes to export dir. So basically that's a directory with name export dir that is base 64 encoded. And if we grab the file name and we decode it, the file name actually is export.txt. So this file is just a text file with instructions to the printer for the exports. So if we just open that file with a text editor, we can see, so ignore this first line, I will explain that in a minute, but in the original file you will see just these two lines. Basically it tells to the printer that it have to export the work files and the config files. So if we go here to that code, basically this is the code that is reading this export.txt file, and it is looking also for this underscore password line, and if there is such line and it is set to 1, basically what it does is it's setting this variable here to enable. And we can see here in the code that is actually exporting the configs, that is archiving the configs and the work files. Here it checks for that variable, and if it is set to disable, which is the default, it password protects the archive. But if this variable is set to anything else, it creates the archive without password. So what that means is that if you edit this config, this export txt file, and you set this first line that I have here, if you set it to 1, your printer will export the works and the config in zip archive that is not password protected. So I'm not really sure why Anycubic refused to give me the password and why they didn't tell me how to export the archives without password. Because there is nothing to hide there, that's just the work files and the config files from your own printer. But anyways, I was able to unzip the archives, and the first thing I did after I unzipped them successfully was to copy that password and just Google it. And when you Google that password, you have only one result. And it is for the Kobra 3 firmware that is already in GitHub. And yeah, they're using the same password for Kobra 3 and for Kobra S1. Here it is. So, all that
serial connection to the printer, and all that effort to extract the file system was in vain because the password is already public here in the Cobra 3 firmware. And the other interesting thing is that here from the Cobra 3 firmware, you can also find the SSH credentials that you can use to SSH connect to your printer. So uh, they are the same. I will put them in the video description also. And basically the username and the password for your printer are username is root and the password is rockchip. So I already showed you how to get your printer IP address and you can connect with SSH by this command. The username is root, then my IP address is 192.168.2.231 and the password is rockchip. And this basically is the Linux console of your 3D printer. So you have to go to the root of the file system and if we list it, here are all the folders that are on the file system. So yeah, all the serial connection to the motherboard was totally in vain because I have SSH access to the printer and also the password for the works is already on the internet. And here I have to say that you have to be very, very careful because this printer has SSH service running and it uses the default username and password, which is root username and rockchip password. And make sure that you do not expose your printer to the internet. Otherwise, anyone will be able to SSH to your printer and do all sorts of stuff from there. So yeah, that's not very good cybersecurity practice. First of all, there is no way to disable the SSH service from the printer configuration from the display or the web app. And there is no way to change the username and the password for the SSH from the printer menu from the configuration of the printer. So yeah, be very careful to not expose your printer to the internet. Okay, so with that said, let's see what happened next. Okay, so after I was able to extract the logs, I examined them and basically this file here, which is named gklib.log, is the main log of the system during the print. And if you take a look at it, so from this log you can extract some useful data. For example, these lines here are outputted during the calibration, the auto leveling of the hotbed. So you can see the results of each of the 25 points. And here is the value from the z-axis. So yeah, if you're doing something with your bed leveling, these results here might be useful to get your heat bed mesh and see what exactly is the warping of your heat bed. So in my case, if we continue down, this is the point when I got the error. And I'm not sure if these walks are the original ones that I sent to Anycubic or these are generated later when I had the same error. But basically, I analyzed all the walks after each error that I get, and they are consistent. So basically, here we have transition to shutdown state, MCU, nozzle MCU shutdown. And this is the reason. Scheduled digital out event will exceed max duration. And basically what that error walk means that there is something happening on the printhead or the communication with the printhead. So basically there is this error that I'm getting. And on some occasions I had another error that is very similar to this one, and it is that move queue overflow. So basically, when the motherboard is sending instructions to the nozzle board, it creates a queue of instructions that the nozzle have to follow, basically. So these instructions are the G code that tells the nozzle to go from this to this point, extrude a certain amount of filament, etc. So this other error, move queue overflow, means that the buffer that is dedicated for this move queue is full and there is no place for more instructions. And what I also saw in some of the walks is that there is a huge amount of invalid retransmitted bytes from the serial communication between the nozzle MCU and the motherboard. So all these three clues from the errors show me that there is something wrong with the nozzle or with the communication between the nozzle and the motherboard. Or there is something on the nozzle side that is causing the motherboard to just give either wrong instructions or yeah, something wrong with the instructions given from the motherboard to the nozzle MCU. So the first suspect that I had was the aftermarket nozzle that I'm using, because the thermistor on the original nozzle is giving 200 kilo ohms resistance in room temperature, and the aftermarket one gives 260 kilo ohms. And that's pretty close, but also the thermistors are very different. The original one here is big with metal housing, and the aftermarket one is really small with glass housing. So it might be that the beta curve of the thermistor are different for the different thermistors. And basically, when the motherboard is calculating the pulses to the heating element, it is using the beta curve from the original thermistor, and if it's very different from the beta curve of the new one, that might cause these overflows and max duration errors and things like that. So what I did is I took out the thermistor and the heating element from the original nozzle, and I put it on these aftermarket nozzles that have the wrong thermistor there, but the housing is very similar to the original one. And I started a new print, and it failed. So
Okay, so let me show you how you can take out the thermistor and the heating element from the hot end. And it's really easy to take them out. So this here is the thermistor, and this here is the heating element, and they are very different from the thermistor and the heating element of this type of nozzles. So this is my original hot end that came with the printer, and you can see that the nozzle is virtually destroyed by that grinding on the build plate. And I transferred the original thermistor and the heating element to this nozzle. This is basically the housing of this nozzle is pretty much the same as the original, but it has the wrong thermistor, and this is the wrong thermistor. So it's the same type of thermistor, it's the same housing, but it has the wrong values. And the heating element is pretty much the same. So to take them out, you need to remove first this silicone sleeve here, and when you remove it, you're exposing this screw here that's inside the body. And this screw, you just take your Allen key, the smallest one that came with the printer, and just untighten this screw a little bit, just a little bit. Do not take it out all the way, and then the heating element will just come out. Then you can unscrew this screw on top with the same Allen key, and when you remove it, you are able to take out the thermistor. And then when you get this out, you can transfer it to these hot ends that are virtually the same as the original one, but they have the wrong thermistor here. Of course, you can try to also to transfer only the thermistor, but there is a very big chance that you break these legs here. So if you transfer anything, transfer all the entire thing, not just the thermistor. And if we take a look at that aftermarket nozzle, the different type of it, the heating element is ceramic, and it's very different from the original one, but it has the same resistance, which makes it virtually the same for the electronics. But the thermistor is very different from the original one. First of all, the original one was giving us 200 kiloohms in room temperature, and this thermistor here is giving us 260 kiloohms. So obviously that's different, not by much, but different. And because they have very different housing, you can see that the old thermistor is metal, it has big metal housing, and this one you can just take down this metal bracket here, and just the thermistor is sitting inside this hole here, and if we take it out, it's much different. That's a glass housing thermistor. It's very small, and obviously it's have different values. So yeah, I can confirm that this is working well. That's not causing the problem. But my initial thought was that because these thermistors are different, probably the beta curve of the thermistor is also very different, and that's what might cause the issue. But no, it was not that. So I think these are safe to use and they work really well. They hold temperature very well, they cool down and heat up very fast, and they are much stable. So what I observed with the original hot end was that, for example, if I set the temperature to 240 degrees, what this hot end is doing is it goes up, it reaches around 246 degrees, then it turns off, it goes down to 232 degrees, then it turns on, it goes back up to 246, then back down, and it's like a cycle. With these hot ends I see much different behavior. So basically it goes up to 240 and it stays there all the time. There is almost zero fluctuations. Rarely that goes up to 241 or 239, but most of the time it just stays at 240, which I think is better behavior than this one. Okay, back on the computer.
That's how I ruled out that it's not a nozzle problem. So after that, the main suspect was the something wrong on the nozzle board, basically. So the first thing, and let me show you a image of the board, the nozzle board, the printhead board, and yeah, let's see which one will be the best. Okay, let's use this image, and basically this is the printhead board, and here on the top is the main connector that is for the cable going to the motherboard, and down here this is the connector that is for the nozzle. Basically you plug the nozzle here, and right next to that nozzle connector, this 8-pin chip here is the MOSFET that is controlling the nozzle heating. And the next suspect was this MOSFET. And That's a weird packaging for a MOSFET, but basically I think all the pins or that side are shorted together and they are, I think, the drain, and then the first pin here is the gate, and then the other three pins are the source or something like that, I'm not sure. But basically I measured this MOSFET and the resistors that are connected to the MOSFET, and everything looked good and nothing out of the ordinary. At this point, this ruled out the MOSFET as a suspect for the issue. So, at this point, I had basically two suspects left. One was the entire board. Something is wrong with the entire printhead board. And if that's the case, there is nothing I can do at this point because I'm waiting a new board to come probably next week. So until then, there is nothing I can do. And the other suspect is the main cable that is going from this connector here to the motherboard. And what I did was I disconnected the cable on both sides. I measured the resistance of the cable, I wiggled it around to make sure that there are no breaks when it moves. I also traced the cables from the connections on the boards to the other connection on the board to make sure it's not something that is disconnecting here on the connector side, and everything looked good. So this ruled out the theory that there is something wrong with the cable itself. So now I was left with two theories. First, the board, that I have nothing I can do right now about it. And the other theory was that something is causing noises in the cable, in the serial communication between the printhead board and the motherboard. And as I told you earlier, here we have 8 pins, only 7 of these are used, and 4 of the pins are two 24-volt lines that are coming from the motherboard. And the other 3 pins are for the serial communication between the motherboard and this board. And that's a fairly long cable from here to the motherboard, and it's moving. And the main thing I think is the issue here is that here on this square hole fits the uh, the extruder motor and the stepper motor of the extruder. And basically, when these motors are running, they're generating a lot of electromagnetic noises around them. And this connector is right on top of the extruder motor. So what I decided to do until my new board arrives, is this. So this monstrosity here. So what I did was, so here is the extruder motor down here, and right above it is the connector for that cable. And what I did is I created a copper tape shielding on top of the cables. So here, up here, the insulation of the cable ends here, and then from here down to the connector, the wires are exposed. So I did metal shielding, copper tape shielding on top of the wires. Then I connected a wire to that copper tape shielding, and I connected the wire here to ground. And I did exactly the same thing on the other side where the cable connects to the motherboard. And basically what this does is insulate the cables and give a way for the noises to go directly to ground instead of interfering with the serial communication cables. And guess what? After I did that, the print, the 15-hour print, finished successfully. Exciting, right? So yeah, this, in my case at least, this is what was causing the issue. And I think that this motor here, the stepper motor for the extruder, is generating a lot of electromagnetic noises. And without that shielding, your serial communications is interrupted at some points, and the software is piling errors, and the queues are getting overflowed because basically when there is an error in the serial communication, the queue cannot be flushed, so the motherboard is keep adding events to the queue and it gets overflowed at some point. So yeah, this is what solved the issues, for me at least. And that was totally unexpected for me. I was expecting to have issues with the board itself, and this was just a wild guess while I'm waiting for the board to arrive. Okay, so to sum it up for this printer, in these 4 parts of the series, in the first part, solved the issue that I had with the pressure sensor. And I have to say that this type of pressure sensors are very unlikely to become faulty because it's just a metal piece that is calibrated and it's very strong metal. And unless you break the wires that are going to the metal piece, or you apply a huge force on the metal and bend it out somehow, there is almost no other way for these sensors to become faulty. So the issue there is probably not with the sensor, but with the plastic housing around it. And with time, it probably gets deformed somehow, and it causes for the radiator, the heatsink that the nozzle comes in it, to touch something and basically give weird and false readings for the pressure sensor. And the second thing I did was replacing the hotbed, because I almost destroyed mine trying to level it perfectly. And the things I learned from that is that the hotbed leveling doesn't matter that much, because if the pressure sensor and the auto leveling system is working properly, the printer should be able to compensate for this unevenness of your hotbed, and even if your magnetic layer is damaged somehow, when you put the build plate on top of it, this doesn't matter. So I see a lot of people on the internet going crazy trying to level the hotbed perfectly, like 0.1 millimeter perfect. And I think that this is a total waste of time, and that's what I was trying to do, and it's totally in vain, I think. So that's one thing I learned here. And the second thing I learned that there is a design flaw on this printer on the back side of the hotbed. There is only one axis, and that causes a wobbling on the back side of the build plate, on the back side of the hotbed. And in order to mitigate that, in the second video, you can find in the description, you can find the 3D model of a bracket that I used to support the backside of the hotbed. And that still is not solving the issue completely. So I think that this printer should have two axes on the back instead of one. Then I have found out that probably in order to save some money, they skipped to put bearings on the z-axis rods, on top side of the z-axis rods. And that is causing wobbling of these rods. And this is most probably the cause of bad print quality on the z-axis when the layers are misaligning, and basically when the print head moves, that probably causes a wobbling on the z-axis rods, and that is why there are artifacts and movement between the layers. So maybe in the future, at some point when I have enough time, I might try to add bearings on the top of this axis and see if that changes anything. So the next thing that we learned about this printer is that this design here that we see on this image is not very well thought, and it's not very smart to put the serial connection wires right on top of the extruder motor because of all the noises that are coming out of the motor, interrupting the serial communication between the print head and the motherboard. The other thing that it turned out there is no overheating issue, at least for now, but yet I'm thinking that it is not very good idea to put the motherboard on the hottest place inside the printing chamber. So probably it's much better idea to take it out on the backside of the printer where is the power supply and the driver board, and there is more than enough space there to put that small motherboard. And probably the last thing that I have to mention here is that on your printer there is an SSH service that is running. So port 22 is opened, and the SSH connection is using the default username and password, which is root for the username and the rockchip for the password. And that's not a good cybersecurity practice. So make sure that your printer is not exposed to the internet. So pretty much that's it for this video, and I'm not sure if I will make another videos from this series, but if I encounter another problem and if I do anything related to that printer, I will create a video and will upload part 5. Thank you very much, guys. I hope you learned a lot, just like me, and have fun printing. And with this printer, have fun fixing. Probably I should say that last. So if I can go back in time and make again the decision to buy this printer now that I know all the stuff around it, I am not buying it again because I lost almost a month of my time to debug it and find this stupid issue here instead of doing my job and printing the prototypes that I have to print. So I would probably buy something more expensive, probably 2 or 3 times more expensive than that, but something that is just working, because it's much better to give more money for something than less money for nothing. Okay? Be safe out there. Bye.